Boys, today we're looking at reflections of functions. So we're going to look at a number of different ways that we can reflect a function in the xy plane. The first of these is looking at y equals minus f of x. So we'll sort of start to understand this by looking at an example. So let's look at question 1. For each function, sketch the graph of y equals f of x and y equals minus f of x on the same number plane. Okay, so thinking about this function here, okay, so this function is x squared minus 2x. Now that's a parabola that's concave up. In terms of trying to draw it, if we wanted the x-intercepts, they would occur at f of x equals 0. And so if you factorize that, you're going to get 0 equals x outside of x minus 2, which means that the x-intercepts, x is going to be equal to 0 or x is equal to 2. If that's the case, then the axis of symmetry is going to be at 1. Could you just find the halfway between the point of those one? We're at 1. And in fact, if I put it into sort of the vertex intercept form, or the vertex form, I would get that the vertex is going to be at 1 minus 1. Alright, and so if that's the case, then if we graph this guy, there's the vertex, and it's going to go through 0 and 2, so we get some sort of concave up parabola like that. Okay, so what's the other function going to look like? Minus f of x. Well, if we do the maths on that, minus f of x is going to be minus x squared minus 2x, which is equal to minus x squared plus 2x. And if we think about that one in the same way, that is also going to have x-intercepts of the x-intercepts will also be 0 and 2. So if you factorize, you still get the same outcome. But this case, the vertex, well, now I guess the axis of symmetry is the same. The vertex in this case is going to be at 1, 1. And so essentially what happens in this function is that it sort of flips it upside down in the x-axis. And so it's still going to go through here and here, but the vertex will be up there, and so it's going to go loop up and loop down like that. And so this function that we've got here, this is f of x, which is the red one, and f of minus x is the other one. So it basically flips it in the x-axis. Looking at B, that's a cubic, and so it's your stock standard cubic that looks something like this. and this, so that would be f of x. And so what would happen if you reflected it in the x-axis? Well, this part here is going to flip down into the bottom, and this part here is going to flip up to the top, so that part will go down there. And so if I draw the function now, it's actually going to look something like this. Then that would be minus f of x. And minus f of x, of course, would be the function minus x cubed. So for this particular minus f of x, we have, what happens is it changes the sign of the y values from the original function from positive to negative, or negative to positive. On the number plane, this means reflecting the graph in the x-axis. So that's the summary there. The graph of y equals minus f of x. The graph of y equals minus f of x is a reflection of the graph of y equals f of x in the x-axis. All right, looking at now the next set of examples, which is looking at y equals f of minus x. We've already seen that some functions are even or odd by finding f of minus x. We can see the relationship between f of x and f of minus x by drawing their graphs. So for each function, sketch the graph y equals f of x and y equals f of minus x on the number plane. So let's look at the first one. So that's that same cubic we just saw, except it's gone plus 1 in the axis. And so if I drew this, it would instead go through, well, that's actually 2, so this would be 1 here. And so my function would go through go through like this. That would be f of x. Now, f of minus x would be this function. Which is the function, again, it's going through 1, and except it's sort of been flipped to be the negative version. So this function is going to look like this. And so what's happening here is that the function, when you do f of minus x, is not flipped in the x-axis, it's flipped in the y-axis. So it's a reflection of the graph in the y-axis. So if you use that as your mirror, that y-axis, then that shows you where the graph ends up. Alrighty, let's look at the next example. Here we go. So f of x equals 1 over x minus 2. So what function is that? Well, that one is a hyperbola. And what's notable about this hyperbola is that it's got an asymptote at 2, so you can't have x value of 2. So if we're going to draw that on the number plane, 2 is going to be an asymptote. So it can't go through 2. And the other asymptote is the x-axis, because y can't be 0. So with those in mind, we can then draw the graph. So it looks something like this. Now, what happens if I flip this in the y-axis? Well, what would happen is all of this part is going to flip over to there, and all this part is going to flip that way. This asymptote here is going to jump over to there, and well, the asymptote for the horizontal one will still stay the same. So if we now try and draw in the version for y equals f of x, f of minus x rather, then that's going to be equal to 1 over, and we've got minus x minus 2. And so if I now take out that minus sign, I get minus 1 over x plus 2. So for this function here, x cannot be equal to minus 2. If I put minus 2 in there, it's going to be 0 in the denominator. It's not going to work out. So that's where my asymptote will be, at negative 2. And so there's that asymptote we were talking about at negative 2. Now where's the rest of it? Well, I don't have to stress too much about subbing things into the equation, because I know if it's reflecting it in the y-axis, this whole red part over there is going to be flipped over to here, and this part down the bottom is going to be reflected in the y-axis like that. And so that is f of minus x. It's a little bit messy, but I would encourage you to graph both this, the two different functions. Let's get a different color, that one and that one in Desmos, and you'll be able to see how it works. So y equals f of minus x changes the sign of the x values from the original function from positive to negative, or from negative to positive. On the number plane, this means reflecting the graph in the y-axis. Okay, the last one we're going to look at is the graph of y equals minus f of minus x. Well, so if we remember the this function that we had earlier when we were looking at minus f of x, we saw that we had this function here that had these different points. It was a parabola like that. When we reflected it in the x-axis, it got us a function that looked like this. And so that is minus f of x. Now what we're asked to find is minus f of minus x. So we've already got minus f of x. We just need to put a minus now inside the brackets there. And what's that gonna do to the graph? Well, that's gonna reflect this red graph in the y-axis. And so